In this video, we're going to look at integration by parts. Here is the formula for integration by parts that's given in the book. So the first thing we'll do is derive this formula. And the way we do it is by starting with the product rule for differentiation and deriving a formula for integration from that. So there's the product rule. The derivative of u times v is u times the derivative of v plus v times the derivative of u. So let's integrate both sides of this equation with respect to x. So the left side is the integral of the derivative of u times v, which is just u times v. On the right side, the integral of u times dv dx becomes u dv. There are some mathematically rigorous details we're skipping over there, but this kind of reasoning works fine for the kinds of functions that we'll be looking at. And similarly, v du dx becomes v du. Finally, I bring that v du term across in order to get the version of integration by parts that's given in the book. So integration by parts is like a rearrangement of the product rule for differentiation. So the question is, how do we apply this formula? So let's go to an example. So here's our first example. The integral of x times e to the power of 6x dx. Now, let's first notice you can't do this by substitution, because you might try something like u is equal to 6x, but the derivative of that would be just 6, and you'll never be able to get rid of that x in front of the exponential. So what we need to do is pick a u and a dv and try and apply our integration by parts formula. So here I'll pick u is equal to x and dv is equal to e to the power of 6x dx. So now for my formula I'm going to need du and I'm going to need v. So to get du from u is simple enough. I say du dx is equal to 1. So du is equal to dx. I'm also going to need v. So to get v, I can just integrate my dv equation. So if dv is equal to e to the power of 6x dx, then v is equal to the integral of e to the power of 6x dx. And that is equal to 1 over 6 e to the power of 6x. So now I have uv and I have du, so I can apply my formula. So the integral of x times e to the power of 6x dx, so that's the integral of u dv, it's going to be equal to u times v, so u is equal to x, v is equal to 1 over 6 times e to the power of 6x, so there's my uv, minus the integral of v du. So v is again 1 over 6 times e to the power of 6x, and du is equal to dx. So now I have an integral which I can do here on the right side. So that's equal to x over 6 times e to the power of 6x minus that 1 over 6 will stay in front, and then the integral again of e to the power of 6x dx is 1 over 6 e to the power of 6x plus c. So at this point I'll put in my arbitrary constant. I could have put one in when integrating dv, but it just would have been an extra one added on. So that's equal to x over 6 times e to the power of 6x minus 1 over 36 e to the power of 6x plus c. And that is integration by parts. So let's look at that step by step. So the first step would be to choose your u and choose your dv. Step 2 is to differentiate u to get du dx. Step 3 is to integrate your dv in order to get v. Step 4 then, you have u, you have v, and you have du, so you can now apply your formula and substitute in all those things into here, and you'll have u times v, something which requires no more integration, minus the integral of v du. So your final step will be to do that integration of v du. Now hopefully this last step is something straightforward. I mean, it's an integral you can do directly, but sometimes that integral might actually still be a difficult one, and sometimes you may actually have to do another integration by parts. But in general, the idea is that by applying your integration by parts formula, you're left with an integral there, v du, that you can actually do directly. So that's integration by parts. In the next video I'll go through some more examples.